Assalamualaikum and hi. My name is NURIN binti Muhammad RADZUAN. Today I want to present my final year project. The topic is heavy metal determination and high risk assessment of edible mushroom collected from selected market in Kelantan, Malaysia using atomic absorption spectrometer AAS. Mushroom are low energy content and a high concentration of important biologically useful elements. However, heavy metals such as mercury, lead and cadmium are accumulating at higher level in mushroom species than in other edible plants. Accumulation of heavy metal in the human body has been shown to be harmful to health. There are three problem statements in this research, which is: first, the majority of people were unconcerned about heavy metal in their food intake, especially edible mushroom. Second, heavy metal can contaminate edible mushroom waste matter from the soil that reach the mushroom body, and those can be accumulated at high level of concentrations. And the last one is presence of heavy metal in soil, water and living object is a major public health issue. The significance of study in this research is proof to local people that some species of mushroom contain high amount of heavy metal, and edible mushroom will easily contaminate by heavy metal through the soil. Last, identify information on heavy metal concentration in edible mushroom and the dietary consumption of their consumers. There are three objectives of this study. First, extract heavy metal concentration from 4 types of edible mushroom: Pleurotus austratus, Lanternula edulis from Lina veletupis and Agaricus bisporus, collected from selected market in Kelantan, Malaysia. Second, determine of heavy metal concentration present in edible mushroom using atomic absorption spectrometer AAS. The third is evaluate of high risk assessment in consuming 4 different types of edible mushroom at Kelantan. Then the scope of the study is gather all the data and information about the concentration of heavy metal present in edible mushroom collected from selected market in Kelantan, determination of heavy metal in edible mushroom to track their high degree of zinc, cadmium, copper, lead and other essential metal. And last, compare the data obtained with the permitted level of the heavy metal that highly suggested by WHO and FAO. Table 1.1 show the list of a scientific name and common name of edible mushroom to be chosen as samples. Heavy metal, it is a natural process and human activity that all contribute to the presence of heavy metal in the atmosphere. Some heavy metal are hazardous to human health even at trace levels. The classification of heavy metal have 2 groups, which are non-essential metal and essential metal. For non-essential metals such as aluminium, cadmium, mercury and lead, toxicity increase with growing concentration, no proven biological role. Essential metals such as copper, iron and zinc, toxic at high concentration and considered to play important biological roles. Then, species of edible mushroom. There are more than 2,000 species of mushroom in nature, but only 25 are considered edible and only a small number are used commercially. Then, heavy metal in edible mushroom. According to the previous research, Pb, Cu, Fe, Cd and Zn readily accumulate in greater amount in the caps, while Mn and I appear to accumulate more in this type. Some of edible mushroom species store large amount of heavy metal, but some of them have a low ratio of metal.
Table 2.1 Summary of previous study. Table 2.2 All the maximum residue limit of heavy metal concentration.
Toxicity of heavy metals. All these heavy metals can cause serious heart problem, and overexposure to zinc can result in fever symptom or liver disease if consumed too much. Long-term exposure to high level of copper through polluted food and water supply may cause copper toxicity. Cadmium toxicity occurs when a person inhale high level of cadmium from the air and consume food and drinks water that is contaminated with cadmium. Effect of heavy metal. It can give effect to human and environment. Heavy metal accumulation in the human body causes significant damage to various organs, and heavy metal used in drinking and natural water sources contaminate the natural environment in both direct and indirect way. Next, influence heavy metal in food security. Heavy metal level in food have exceeded standard threshold and may represent a threat to food security and living form. This is method of study in heavy metal residue. Use atomic absorption spectrometer AAS instrument, and high risk of heavy metal can be determined by comparing predicted tree. Atomic absorption spectrometer, most commonly used method for quantifying heavy metal in environmental samples. Common option for uncomplicated trace elemental analysis because it has an infinite number of applications and has a wide range of application in chemistry. Health risk assessment, target hazard question THQ and health index HI will be used as a method to measure the potential of health risk, and essential part of the environmental protection strategy for protecting people from contaminant in health risk.
Table previous study on high risk assessment for adult.
Of study in Kelantan, that sample will be purchased from selected market in Kelantan. The instrumentation used is atomic absorption spectrometry AAS, and microwave sample preparation device was used. This is the list of chemical and reagent in table 3 and table 4. Show list of laboratory apparatus. Collection sample is from 4 species of edible mushroom. Then the preparation of blend reagent that prepare 5 ml nitric acid, 5 ml sulfuric acid and 1 ml hydrogen peroxide, then dilute with deionized water. Next, sample analysis for determination of heavy metal residue by atomic absorption spectrometry. Digestion method that will be used is dry aging digestions. All the 4 heavy metals, zinc, lead, copper and cadmium will be analyzed by using the AAS, and data will be displayed in microgram. The survey conducted by Google Form and provided by 4 sections. The survey was placed to the respondent at Kelantan. For the high risk assessment, assess through estimate daily intake, estimate weekly intake, target hazard question and hazard index. Metal concentration in different edible mushroom species. Following table 4.1, which is the highest concentration is zinc 1.3, whereas the lowest concentration recorded in cadmium 0.013. The result were obtained by calculating the average amount of mean concentration, zinc, copper, lead and cadmium in the edible mushroom sample in the unit of milligram per kilogram. The concentration of heavy metal in edible mushroom sample were found to be in the following order, where zinc, copper, lead, cadmium. Analysis of vital elements. Zinc. All the mean concentrations of zinc in 4 edible mushroom species is higher but still lower the permissible limit. Figure 1 shows the graph of concentration zinc, and table 4.2 shows the comparison of the level of zinc. Then copper. The maximum concentration of copper was found in Agaricus bisporus, which the concentration 0.193, whereas the lowest concentration was found in Lentinus idoides at a concentration of 0.059 milligram per kilogram. The result also revealed that the mean concentration of every edible mushroom sample did not exceed the WHO per FAO permissible level, which is 40 milligram per kilogram. For result analysis of toxic element which lead, each of the 4 edible mushroom sample examined had a significant quantity of lead, and the result of the research indicate a low level concentration of lead. Last method is cadmium. All of the edible mushroom sample had cadmium concentration that were consistently below the detection limit. The highest concentration of cadmium are shown in Puritas austratus, which a value of mean concentration 0.02 mg per kilogram. However, cadmium concentration were found to be the lowest in Lentinus idoides and Framulina veletupis. For the survey conducted part, there are 371 respondents in total that are taking part in the survey, which include all Kelantan residents from all districts in Kelantan. The outcome from the survey is separated into 3 categories, which are social demographic of respondent, understanding of respondent toward heavy metal, and the frequency of edible mushroom consumption by respondent. From the result, 232 female respondents and 139 male respondents are taking part. Next, high risk assessment. Estimate daily intake EDI for adult in edible mushroom species were found that zinc is the average highest ADI that can be claimed as required the most by adult, especially Puritas austratus. And estimate weekly intake EWI for adult in edible mushroom species also determined that zinc is the most abundant metal, followed by copper, lead and cadmium. Last, target hazard equation THQ and hazard index HI for adult in edible mushroom species. The HR result come out to be 0.001. There is no significant risk in 4 edible mushroom species purchased from selected market in Kelantan because the hazard index HI values are less than 1 and the edible mushroom are safe to consume. Conclusion. The mean concentration of heavy metal identified in 4 edible mushroom species in this research were coming out with different level of concentration. All the mean concentration was sorted in increasing order, with cadmium, lead, copper and zinc being the most prevalent. The concentration of zinc accumulating in edible mushroom were found to be the highest of the 4 heavy metal observed in all edible mushroom species. Lastly, the future recommendation is research about heavy metal and other probable contaminant in other types of edible mushroom, such as canned mushroom and mushroom product. Compare the different types of mushroom species and explain how mushroom can accumulate heavy metal in different areas. Conduct a face-to-face interview or distribute a paper form for the survey sections.